trigonometric equations. Okay, this is going to be our trig laws that we looked at last lesson. Okay, or we found last lesson. The fact that sine x is equal to sine of 180 minus x, cos is equal to cos of 360 minus x, and that sine and cos repeat every 360 degrees, but tan every 180. That's going to be really important. The types of questions we're going to get, it's going to be what looks really, really simple trig equations, the sort of thing that GCSE did to finish off to solve for SOHCAHTOA. Okay, but the new bit that you've got to be careful of is you are now given a specific range for it to be between. So I want all values between 0 and 360. Okay, to begin with, we solve in exactly the same manner. So if I know sine theta is a half, I can just do sine to the minus 1 of a half to give me what theta is. Okay, so using your calculator, sine to the minus 1 of a half, and I get an answer of 30. Now, what we now need to be careful of is 30 is not the only answer. Okay, so if we think about what our sine graph looks like, 360, 360, there is more than just one point where sine will equal a half. I will have 2 points. Okay, one will be at 30, and then I'll have another one in here. And this is where our trig laws become really, really important. Okay, because I know for sine x, so sine of 30 is the same as sine of 180 minus x. So that means I've got one answer at 30. I also have theta equaling 180 minus 30. So I also have it equaling 150 degrees. So I have two answers, guys. Okay, and what you've got to make sure is that you find all answers that are possible. Okay, let's just have a look at another one. This isn't massively difficult as long as we remember to look at all answers within that range. So 5 tan theta equals 10. Okay, exactly the same as what you would have done last year to solve for SOHCAHTOA. I'm just going to move my 5 across. So I'll get to tan theta equaling 10 divided by 5, which is 2. Therefore, I can find theta by doing tan to the minus 1 of 2. So I can find theta as being 63.4 degrees. But that's not all I want. Because I want it between the values of minus 180 and 180, I've got to think quite carefully. So I know that tan repeats every 180 degrees. So I don't want to add 180 onto this because I'm going to go over my 180. So I want to take off 180 from it. Okay. Again, if you need to, guys, you can always think about what your tan graph's going to look like and the fact that you're going to have these asymptotes in place. So if I've got one answer at 63.4, which is going to be here, for me to then get another one between minus 180 and 180, I want this value here. So it's going to be minus 180 away. So I'll have 63.4, subtract 180, and that's going to give me minus 116.6. And they will be my two solutions. Okay, so you've got to read really, really carefully what range you are being asked for it to be between. Okay, if you need to make a drawing just to confirm to yourself what you are looking at, please do, because these drawings can be really helpful. I still use them quite a lot. Okay, if not, you've always got your trig laws, that you can put into place. Okay, but being able to use a combination of two of them is what is really, really helpful. Okay, that really does make a big, big difference. Okay, right. Sine theta is equal to minus a half. Okay, and again, I'm looking between the range of 0 and 360. Okay, first step, find the answer the calculator gives out. So we're going to do sine to the minus 1 of minus a half to give us theta. So theta is going to be minus 30. Now, what you'll find is the answer you're given is not always within our range. Now, a calculator will always give us something called the principal answer. Okay. Now, that principal answer will always lie as an acute angle. It's always going to be somewhere between minus 90 and 90. And that doesn't necessarily mean it's going to be an answer that we want, okay? Because it's not always going to lie between our range like this one doesn't. So we now need to be really careful. So if I think about what my sine graph is going to look like, okay, the answer I'm given is minus 30 degrees, which is going to be here. Okay, the two answers I want are the two further down the graph. Okay, now I know that sine repeats every 360, so I can find this one here nice and quickly, because I know if I just add on 360 to minus 30, I'm going to get one answer at 330 degrees. Okay, then I've just got to think carefully about how I get this one. Now, because of how symmetrical these graphs are, if I know that distance there is 30, I know that that distance there must be 30. So my second answer can come from doing 180 degrees, because that's going to be my intersection point of my sine graph, add on 30, so my other answer is going to be 210. So the answers I'm interested in aren't always necessarily the ones that come out of the calculator. The two answers I want are 210 and 330. The minus 30 I've got up here is of no use to me. Okay, it helps find the other ones, but that is not an answer you would give. Okay, last one I want to have a look at. I'm going to combine some of the stuff you've already done today as well. So, sine theta equals root 3 cos theta. Now, straight away we've got an issue in the fact we've got two trig functions or trig ratios in the same question. I can only ever work these out when I've only got one function, okay, or one ratio. So I'm going to have to do something with sine and cos to make it into one. Now I know with sine theta and cos theta that sine theta over cos theta is the same as tan theta. That's what you looked at earlier. Both sides by cos theta. So I can get sine theta over cos theta equals root 3. And I know sine theta over cos theta is the same as tan theta. Now I'm into this position, I can find what theta is, because theta is going to be tan to the minus 1 of root 3. So theta on its own, tan to the minus 1 of root 3 gives me an answer of 60. So I've got an answer at 60 degrees. Again, we'll just double check what range we want our answer between. We want our answer again between 0 and 360. So I've got one of my solutions. I know tan repeats every 180 degrees. Okay, because again, we've got our tan graph. Okay. If I've got one answer at 60, which is here, I can get another answer over here. So I can do 60 plus 180. So my second answer is going to be 240. And there are my two solutions. Okay, so I've got 60 degrees and I've got 240. You are going to have to put both bits of knowledge that you've done today together. Okay, because some of these you do have to manipulate using the identities first before solving. You need to use your trig angle laws and use your graphs to make sure you get all the solutions. Please, please, please double check each time you do this to make sure you've got all the solutions. Make sure you're going exactly between the range it's asking for, and this becomes a lot simpler. Okay, right. Two questions for you to have a go at. Can you please pause the video now and have a quick go at them, paying particular attention to the ranges they are between. Right guys, let's have a look through them then. So, first one, 2 cos theta equals root 3. So I need cos theta on its own. So I'll have cos theta equals root 3 over 2. So theta is going to be cos to the minus 1 of root 3 over 2. So I know that cos theta should equal root 3 over 2, cos theta should equal 30. Okay. Now I need to double check what range I'm working in. So my range is going between 0 and 360 again. Okay. Cos looks like that. So if I've got one answer at 30 degrees here, I know this is going to repeat. Okay. I know it repeats again here. Okay. So if I know one distance is 60, I know the second distance back is going to be 60 degrees. So I'm going to do 360 minus my 30. Okay, because using our trig angle laws, that's what we're working for. So I'll do 360 minus my 30 degrees. And I get a second solution at 330. Okay. Now, I always tend to use the graphs to help me. You do not necessarily need to, okay? If you can remember the trig angle laws really well, you don't necessarily need to use the graphs. For me, using the graphs is always a nice way of just double checking I've used the right one and gone in the right direction, okay? Because you can visually then see it. Just to go through the second one that I got you to do, again, same as the last example, I've got sine theta and cos theta in the same one, okay? I only want one trig ratio. Make sure you divide these the right way round, okay? Our identity is that sine theta over cos theta equals tan theta. So you've got to make sure they are divided the right way round. So I've got to divide both sides by cos theta to get this right, okay? So that means I'm going to have root 3 sine theta over cos theta equals cos theta over cos theta, which is going to be 1. I can then move my root 3 across. So I'll have sine theta over cos theta equals 1 over root 3. Okay, you can see why this can get complicated and you've got to be really careful with your manipulation. Tan theta equals 1 over root 3. So theta, do tan to the minus 1 of 1 over root 3. And theta will equal 30. Okay, same as before. Back to our range. My range is between minus 180 and 180. Okay, so again, either use your trig angle formulas or think about what your tan graph looks like. Say, my tan graph with its asymptotes at 90 and so on. If I've got one result at 30, okay, my other result I'm after is going to be this one over here. Okay. Because none of these, because if that's 180 here and that's minus 180, that's the one I'm after. So the one I want is 30 degrees up from minus 180. So I'll do minus 180 plus 30. So I get my second solution at minus 150 degrees. Okay, that's one of the main reasons why I use the graphs to help me. Okay, rather than just relying solely on the formulas. Okay. Make sure we are comfortable with where these are coming from. The manipulation in here isn't massively difficult, okay, especially if you've got to grips with your identities in the last piece of work. You've just got to make sure you get all solutions that you are asked for between the given range. Right, go back on to show my homework for me, check the questions that I'm asking you to do, then get that marked. Please, please, please make sure you submit your feedback via the link on Show My Homework. I need to know that we've done this and we are happy with it. Okay.